Hello, everyone. My name is Maverick Madison, and I am your guys' UGTA for spring 2026 for IEE 380. And in this video, we're going to be going over a key concept in statistics, the binomial distribution. Specifically, we will look at how to recognize when a problem follows a binomial setting and how to use that to calculate probabilities using your calculator. So when a problem is asking for something along the lines of a binomial distribution, there are a few things you need to look out for. If the question specifically gives you a number of trials being successful or not successful, and those trials are being independent of one another, and if the overall probability of success is given, then you have yourself a binomial distribution problem. So let's start by reading the first part of the problem. Let's say that there is an airline that sells 125 tickets for a flight that holds 120 people. The probability that a passenger does not show up is 0.10 or 10%. So for the first part, what is the probability that every passenger that shows up can take the flight? So in this part of the problem, we're given a scenario where an airline sells more tickets than available seats. And we're also given the probability that a passenger will not show up. And we're asked to find the probability that everyone who shows up can still fit on the plane. And so highlighting the important information of this problem, we're given a fixed number of trials, which represents the total number of tickets sold. Each passenger either shows up or doesn't show up, and the probability of each outcome is the same for every passenger, as each event is independent. So these are all indicators that this is a binomial distribution problem. And so next we can just take a look at what the problem is actually asking. We want the probability that the number of passengers who show up does not exceed the seating capacity. So we're dealing with a less than or equal to probability here. And so because of that, we will be using the binom CDF function in our calculator, which is used for the cumulative probabilities. And this function requires the number of trials, the probability of success. In this case, it's a passenger showing up, and then the corresponding X value or the upper bound. And so being that we're finding the probability that every passenger that shows up can take the flight, we know that a flight holds 120 people. So at the max, we can have 120 people. So we can structure that probability structure of the probability that X is less than or equal to 120. And so there we have all the necessary components to plug into our calculator function. We have the number of trials, which is 125 tickets sold. The probability that a passenger shows up is 90%, as the probability that a passenger does not show up is 10%. And the corresponding X value, or the upper bound, is 120, since we can hold up to 120 people. And so whenever we plug that into our calculator, we get a final answer of 0.9961, or just over 99% that every passenger shows up can take the flight. And moving on to part 2, or part B, what is the probability that the flight departs with at least one empty seat? And so in this problem, we're asked to find the probability that the flight leaves with at least one empty seat. Again, we can identify the key details. The setup is pretty much the same as before. We still have a binomial distribution, and the number of trials and the probability that a passenger does not show up are still the same and remain unchanged. So the difference is in what we're being asked to find. At least one empty seat means that not all the seats are filled. So instead of thinking about the maximum capacity, we can now adjust our upper bound to reflect one fewer passenger than full capacity. So this again leads us to a cumulative probability. So we can still use the binom CDF function in the calculator. And we just plug in the same number of trials. And so since it's asking for the probability that the flight departs with at least one empty seat, that means that the maximum amount of passengers that the flight will hold in this circumstance is 119. Since at least one empty seat implies that one person's not on the flight. There can obviously be much more empty seats, but at the very least, there will be one empty seat, which implies that we have at the most 119 passengers. And so we can plug these components into our binomial CDF function. The number of trials is the same, 125. The probability is the same for a passenger showing up of 0.90, and our x value or upper bound is simply 119. So upon plugging this into our calculator function with the same number of trials, 125, same probability, 0.90 for a passenger to show up on the flight, and the corresponding upper bound or x value being 119, we get our final answer of the probability that the flight departs with at least one empty seat is 0.9886, or just above 98%. So to wrap things up, in this video, we covered many different things. We covered how to recognize when a situation follows a sort of binomial distribution. We were able to cover and identify key components like the number of trials and the probability of success, as well as identifying that upper bound in the problem. We were able to cover and translate word problems into their own corresponding probability expressions. And finally, we were also able to cover and use the binomial CDF function to be able to compute these cumulative probabilities for these problems. So yeah, that wraps up this tutored concept video on the binomial distribution. If you guys have any questions, feel free to come to my office hours or simply just reach out through like email or through Discord. And so yeah, I thank you for watching.